All right. Question I want to pose to you guys, and it can't be exactly the same question for everyone, since some of you are AI guys and some are brain guys. So I asked this at the AGI '09 conference as well. So for people whose focus is AI, when do you think we may have a human level AI? What do you think are the main bottlenecks and issues in getting there? For those of you who are working on the brain, when do you think we'll have a good model of the brain and understand how the brain works, and what are the main bottlenecks and issues in getting there? Of course, these are big issues, and we don't have much time, so we're just looking for a brief summary of life, the universe, and everything from each of you. We can start.
I think that I've heard the number thrown around as 2050 is when we have a greater than a human singularity. I think that if we actually work at this and like quadruple or have 10 times the number of AI researchers in the field, we could make that half. Because there's a ton of work to be done. And what we would need is the number of people doing this work to be multiplied by 10. And for the funding level of the work to be multiplied by 10. The human need graph that was off the charts, that's the demand that we should be considering this field and how important it is. So.
Yeah, I guess I'm kind of going to trend the same way, although I'm going to give my answer for the brain part of it, which is, of course, the expression time is money, which is that how long is it going to take depends a lot on what you put into it. And of course, there's also the question of exactly what are you asking. If you say how much are we going to, be able to understand or model the brain, to which level do we need to understand it? Are we going to be able to simply make something that acts just like a brain, or that kind of we have a model that's good enough that the activity looks the same, but do we really understand what it's doing? There are all those extra aspects. But, Markram said he was going to at least emulate the brain within 10 years, so I'm holding him to it. We'll see what happens.
So I guess I'm going to give a slightly different kind of answer. And I'm very hesitant to answer this kind of question because I think we still don't know what we don't know. And therefore, it's very hard to predict. So I'll say this century. I'm pretty sure we'll get to it then, but I'm not going to predict when within the century. As to what's missing, again, I think there are things missing we don't understand yet, so I can't say that. But what I can say is that what we're good at is building systems with a certain level of capability and then building certain levels of adaptation into them so that they can get a ways beyond what we build into them. What we're not good at is going a step beyond that. So not just, for example, getting learning to go a little bit beyond what you put in by hand, but getting learning to be able to go a long way beyond it, to be able to have a system that will survive for a long period of time, adapting as it goes, improving as it goes, as opposed to a short-term demonstration of some adaptation capability. If we can do that, then I think we're pretty close.
So one of the things that I find really interesting is this idea of multidisciplinary collaboration and people from lots and lots of different fields coming together. And I think that what's happening at the moment is we're starting to see the start of this. So there are people from neuroscience and AI and all different kinds of backgrounds coming together. So I think what we'll see is within the next 5 to 10 years, we'll see more of that. And we'll see some kind of merging of all these fields. Whether or not that will actually result in a human-level intelligence, I'm not sure. I'm not going to predict that. But I think it will result in something really cool, even if it's not that. So.
I guess I'm very pessimistic, partially because my job relies on keeping the questions open. But I'm saying that I'm very pessimistic. I think that as long as we study these, I have a job. So I think that it's going to be... the brain is much more complex than the brain that tries to understand the brain. So it's far, I think. I would say none of the people in the room would get to see the answer, sadly.
I think we need to focus on specific aspects, not to try to solve a general problem of human intelligence, perhaps having the DARPA grand challenge type of things, which are related to intelligence. Perhaps in, 5 to 7 years, we'll have a robot that will display kind of dog type of behaviors of reasonable, passing a Turing test on dogs. Perhaps in about 10, 15 years from very far, we could pass a Turing test on an anthropomorphic robot on kind of like some simple tasks. So again, it's not really so much about thinking, but about the appearance of an intelligent behavior. And I think if we go through kind of focused project and we control or constrain the problem somehow, we will achieve human-level intelligence in the same way we did with no, in chess playing and so on. So it's kind of going to grow up, but I don't know exactly to put a date on exactly beating a human on absolutely every aspect, but probably not in the next 10, 15 years.
So I get to go last. So the question presupposes that there's a specific answer, and my experience is that this is not the way that technology and science works. The length of time something takes is a very strong function of how you attack the problem. So for this one, you need a lot of money. You need a giant team formed of lots of different people from all sorts of different backgrounds, and you need a lot of time over which to solve all of the problems that come up. I don't see this being financed by a government. I don't think that's going to happen. I think that government financing is not a good fit for things of this magnitude. It needs to be financed by a corporation. And the only way that that will happen is if one of these giant corporations really sees a need to do it. I don't mean that they want to do it. I think that they need to do it in order to keep surviving. If all of those things align, and there may be a chance that they do, I'd say between 5 and 10 years we could have systems that are indistinguishable from humans.
All right, so I'll give a brief answer to my own question now. My answer, unsurprisingly to those of you who know my views, is more optimistic than the mean. I guess I think that if there was an alien invasion threatening to kill all humans in 3 years, unless we create a human-level AI, I bet the human race could do it. So, I mean, I'm glad that's not the case, but that's my bet is that we could do it. And so what that leads me to believe is that as several of the others said, there are certainly conceptual problems to be solved and a lot of research work to be done, but there's also a resource bottleneck, which is in a way an attentional resource bottleneck. I mean, in my own work, I mean, I'm dividing my time between practical machine learning stuff and trying to make a thinking machine. Randall is dividing his time between various sorts of different tasks. Many of us are. And I think depending on how much of the attention of the people who are passionate about this topic can get focused on the core problem of, in my case, building thinking machines, or in the neuroscientist's case, fundamentally understanding how the brain works, it could be anywhere from, say, 5 or 10 years to a few decades, and I would be, as Paul said, shocked if we didn't have these things this century. I'd be shocked if we had them next year, and anywhere between 5 and 25 years would not shock me. Right?